Hello, my name is Rob, and welcome to College Algebra Section 2.1. We're going to talk about, in this first section, the distance formula and the midpoint formula. The first thing you need to know is how to plot a point. So if I give you the point 3, 4, this is the x distance, which is moving left and right. This is the y distance, which is moving up and down, and this is called a coordinate point. So I'm going to move 3 units to the right, and then 4 units up, and place a point. So go ahead and practice plotting these points. If you have graph paper, that would be great. If not, just sketch something. This says 6 to the right, 4 up. This says 6 to the left, and don't move anywhere else. This says go 3 left and 5 units down. And this says don't move anywhere, but go 7 units up. After you're done, you should have points plotted like this. You don't draw the lines in between. It's just those are showing directional arrows of how you arrive at those 4 points. The quadrants, this is quadrant 1. This is my positive quadrant. This is quadrant 2. I'm going to move to the left and then up. This is quadrant 3, which is both negatives. The x-coordinate and the y-coordinate is negative. And then quadrant 4 is positive and then heading down to negative. The distance formula is defined as nothing more than the Pythagorean theorem, a squared plus b squared equals c squared. If you solve for c and take the square root of both sides, we almost have the distance formula, because the distance between these 2 points, all I'm going to do is subtract 5 minus 1. You could count the tick marks as well, but that distance is 4. So the distance between this leg of the right triangle can be found by subtracting off the x values, and then this says go ahead and square it. So here comes the distance formula. The change in x's plus the change in the y's. The difference between 6 and 3 is 3, or you could have counted the tick marks again, but I don't always give you a graph. So again, it's a squared plus b squared, and in this case, b is this height, y minus y quantity squared, and there's your first look at the distance formula. It's really the Pythagorean theorem. You should also recognize certain special right triangles. The 3, 4, 5 right triangle happens often. So here's the formula. You don't have to so much worry about x of 2 and x of 1. That's just telling you this is the second point that you're starting from, and you're subtracting off the first point. The order doesn't matter here because you're going to square it. Here's a quick little proof of why that works. These are some examples to find the distance. This is interesting. Don't do the distance formula for horizontal and vertical lines. And the reason why is because it's a waste of time. If you were to look at these, the y values are equal. Whenever that happens, don't go through the distance formula because it takes longer. You don't want to do 13 minus 9 quantity squared plus 2 minus 2. I would not recommend this, because this simply just simplifies to the difference between 13 and 9. This distance here is going to be the difference between 13 minus 9, which is just 4. You don't want to go through the square root here. This is 4 squared, which is 16, and then simplifies that to 4. That takes too long. If it's vertical or horizontal, hey, these numbers are the same, so all I have to do is find the difference between 2 and 5. Remember, distance is never negative. So if you end up with a scenario like this, just make it the absolute value. Distance is always positive. So this distance here, vertical distance, is 3. Again, here's the formula. I've got 2 points. Here's my x and my y. Here's my x sub 2, y sub 2, just for my second point. But again, it doesn't matter the order that we put these in, because we're going to be squaring these. So if I do x sub 2 minus x sub 1 plus y sub 2 minus y sub 1, I should have a nice answer for the distance between the 2 points without plotting them and doing the Pythagorean theorem. Negative 1 minus 2 is negative 3. Negative 3 squared is 9. This really says 3 plus 4, which is 7 squared is 49. And The square root of 58, I don't believe can be simplified. I'm looking for things that, like perfect square that goes into 58. And I don't think 4, 9, 25, or 36 goes in there. If you ended up with the square root of 8, please simplify that to the square root of 4 times the square root of 2, which is 2 square roots of 2. But in this case, the square root of 58, please don't change that to a decimal. Just leave that as the exact answer. This is kind of a longer problem. They want you to plot several points here, -2, 1 for point A. This is 2, 3 for point B, and point C is 3, 1. And they want you to prove to me that this is a right triangle. Probably the right angles right here at B. At least that's what it appears to be. But to prove that it is, I would have to find the distance of AB, find the distance of BC, find the distance of AC, and then to verify that something truly is a right angle, I'm going to show you that A squared plus B squared really does equal C squared. Because if this works, then I know this is forcing this to be a right angle in here, because the Pythagorean theorem only works for right triangles. And then after that, we'll go ahead and find the area. To find the area, I'll know that this is a base and this is a height, because that's what I use. And for the formula for the area of a triangle is the base and the height. This final longest side is called the hypotenuse, and I don't use the hypotenuse to find the area of a triangle. So go ahead and see if you can't find those distances of those three sides by pausing the video. So after you find AB and BC, for the last part, you might want to do AC by doing, again, x minus x. But I noticed something here. For A and C, I have the same numbers for the y, so that makes it a horizontal line. So all I need to do is subtract off -2 minus 3. So I'm not going to go through this. -2 minus 3 is -5, but I know that's the absolute value of that. So I'll just say 5. And then I'm going to check A squared plus B squared equals C squared. Remember, you've got to set it equal to the hypotenuse, the longest side. And the longest side here is 5. So I'll say the square root of 20 squared plus the square root of 5 squared better equal 5 squared. And it does. 20 plus 5 is equal to 25. After you're convinced that it is a right triangle, we can then do the area by doing 1/2 the base. So again, it doesn't matter which one is the base, which one's the height. But this is the square root of 20 times the height, which is the square root of 5. And I'll multiply that out by trying to take the square root of 20 times the square root of 5, which is the square root of 100. And the square root of 100 is 10. And 1/2 of 10 is 5. So I would say that the area is 5 square units. The midpoint formula is a little confusing. Sometimes students mix up the midpoint formula with the distance formula, because for the distance formula I was actually subtracting the x's and finding the difference between them, and same with the y's. So be careful. For the distance formula I'm subtracting, but for midpoint I'm adding because I want to average the points. So an example of this would be finding the middle of something. It's kind of like finding the middle between your grade. If your first grade was 80 and your second grade was 86, you would average them up by adding them and dividing them by 2. So again, the Pythagorean theorem is, here's a quick little proof of how to get to that midpoint. Let's get to an example though. The sum of the x's and the sum of the y's divided by 2. So our first example says, if I'm going to add -5 and 3 and divide by 2, that will be the new x coordinate. To find the y coordinate, I'm going to add the 5 and the 1 and divide by 2. And you can see this is a pretty good estimate. -5 and 3 is -2, which is -1. If I estimate, this was -1, 1, 2, 3. So it looks like -1, 3. But again, I won't always plot it to be nice, a nice point. But this mathematically does work out to be the same point. So the midpoint formula is -1. or yields negative 1, 3. So again, just a quick review of section 2.1. We learned two things: the distance formula. The distance formula is really nothing more than the Pythagorean theorem, a squared plus b squared equals c squared. So to find this purple distance in here, you could do the Pythagorean theorem, or you could do the formula x minus x quantity squared plus y minus y quantity squared. Your test might be multiple choice. See if you can pick a correct solution. I think the correct answer is letter D. And for the last example, this time they're asking me to find the midpoint. Again, I recommend that you pause the video and see if you can't find the midpoint. I think the correct answer is A. I hope this video is helpful in you finding distances and midpoints. If you have questions, email me. Thank you.